Simple conversions are just one-step conversions. They're the simplest type of conversion that there is, and all you have to do is have one conversion factor. Units are really important because the units tell you if your math is correct in doing problems in chemistry. So from this point forward, I want you to look at numbers as being secondary to the units. You must focus on the units. You have to have these units in doing conversions, and when you're using formulas in chemistry, if you focus on the units, it will tell you if you have your setup correctly. Every number must have a unit. First you do your unit math, and then you take the numbers and enter them in your calculator and calculate things. If your units come out correctly, then your numbers should come out correctly. If you ever get your units so that they're in the denominator rather than in the numerator, yet all your units cancel out properly, that indicates you did your math upside down. It's so important to concentrate on units, and what I'm going to attempt in the next few slides is to get you to see why units are so important. Conversions are just based on multiplying by 1. Let's see how this can be. Let's look down here. If you look at this setup right here, b times a over a equals b, you can see this fraction is basically equal to 1. Why? Because a over a is equal to 1. When I multiply b by a over a, I get b back, and there's no change to the measurement. If this were a measurement, I haven't changed the measurement because I'm multiplying by 1. And that's just what we want to do in a conversion. We don't want to change the measurement, we only want to change the way it's being expressed. So how can we get a fraction equal to 1? We can use an equivalency statement. If we look at this equivalency statement, you can see that 1,000 grams is equal to a kilogram. So if I create a fraction from this equal statement, I will get either 1,000 grams over a kilogram, or I can have a kilogram over 1,000 grams. Both of these are equal to 1. It doesn't matter which one we look at, how we put it. If we put the 1,000 grams over a kilogram right here, it's equal to 1. If we put a kilogram over 1,000 grams, it's equal to 1. What's the key thing to make it equal to 1? See where this 1,000 is? It's with the gram. You see the kilogram? No number with it. Well, there's an unwritten 1. So you can, when you go to write this, you have to make sure that 1,000 sticks with the gram. And there's no number or a 1 with the kilogram. Notice the 1,000 is with the gram. So that makes the fractions equal to 1. Now what we can do is go and take a fraction like this and multiply it by a measurement and change the measurement. Let's take an example right down here. If I want to change 4.4 liters into milliliters, how can I do it? Well, I do it in this manner. I take my fraction and I put the unit I want to get rid of on the opposite side of the fraction to it. You see right here, liters is in the numerator, so in the fraction, liters must be in the denominator. That means the milliliter will end up in the numerator. Let's go ahead and look at how we can now make sure we get the right number. Remember that this fraction has to be equal to 1. How do I make it equal to 1? I go back and I remember that milli equals 0.001. So if I take milli and follow with liter, then I can take 0.001 and follow it with liter, and these two are then equal to each other. So liters cancels out, milli ends up being the unit. I then go and I do my math and I take 4.4 and I divide it by 0.001. Why do I divide? I divide because this is in the numerator. Whenever a number is in the numerator, you always put a divided by in front of it. So the answer to this math will be 4.4 divided by 0.001. And if you do that on your calculator right now, what you're going to get is 4,400. And notice the unit you get is milliliter, so you must write that. Don't ever forget to write your unit, because a number without a unit is meaningless. Okay, so let's go ahead and look at an example. So in this example, the first thing we're going to do, we're going to read through the problem and see that it says how many microliters are in 0.0040 liters. So we write down the measurement that's given. What measurement is given? It's pretty easy to find this one because it's the only measurement in the problem. So we write it down, 0.0040 liters. So we start the math with the measurement. The next thing we're going to do is write the equivalency. So we have to go from microliter to liter, so we need a relationship between microliter and liter. To get that, we first start with the meaning of micro. Micro means 10 to the minus 6. So I start with this, and then I follow both sides of this equation with liter. Notice, I have liter after the micro and liter after the 10 to the minus 6. I look up at the measurement and I see that it has liter after 0.004 liter, and I know I need to get to microliter. So I know I have to set up my math so that the units cancel. Let's look at the possible fractions that can result from this equivalency statement. If I look at this fraction, you can see there's microliter in the numerator and liter in the denominator. On this fraction, there's liter in the numerator and microliter in the denominator. Remember, I said to focus on the units. So I only am concerned about units right now. So I go back to my initial measurement and I see that it says liter. So I need to get rid of that liter and go to microliter. So I've got to mathematically get rid of my liter. If I look at these two fractions, what will this one do? This one will cancel liter out because it's in the denominator where this is in the numerator and give me microliter. If I look at this one, there's going to be no unit cancellation going on. In fact, the result of this math will be liter times liter over microliter. You're going to get a crazy outcome. It's going to be meaningless. You want something that makes sense, that says just microliter, right? So let's pick the fraction that will give us that math. Let's place that up there. Oh, first, notice the entire side of this fraction is on one side. Entire side of this equal sign is on one side of the fraction, and the entire side of this equal sign is on this side of the fraction. Always check to make sure you did that. A lot of people will get mixed up and put 10 to the minus 6 microliter with and 1 liter. That's not what the equal statement says at all. You need to always go back and check with your equal statement. That means you have to have written it. So you always write your equal statement, and then you check with it before you form your fraction. That way you won't make a mistake. So now we're going to go and take the fraction that gives us unit cancellation and place it in the problem. Okay, so now we see that liter is canceling out with liter, and we get microliter. That's good. So what we have left now is to do the math. If I were to just do the unit math, I would come up with microliter. Now I have to do the number math, which is 0.0040 divided by 10 to the minus 6. Why is that the math? The reason that that is the math is because this is in the numerator and that is in the denominator. When I have something in the denominator, what must I put in front of it in the calculator? A divided by. How do I put 10 to the minus 6 in the calculator? Well, if you're having any trouble getting that in your calculator, you can come see me in class. If you want to try doing it right now and seeing if you get the right answer, it is that you put it in as 1e negative 6. But if you can't figure it out, don't worry about it. Just come to class and ask for me to show you how to use your calculator, and it'll take about 15 seconds. Okay, so let's go ahead and look at the math here. 0.004 divided by 10 to the minus 6. That's going to give you 4 times 10 to the minus 3. Check on your calculator to see if you get that. If you don't, just bring your calculator to class. You need to bring it to class anyhow. Here's some problems for you to do. What I want you to do now is to pause. All right, here's your first problem. What is the mass of an electron? 9.109 times 10 to the minus 28 grams in micrograms. Well, the first thing, remember, that you do is you write down your given. Okay, so I've written my given here. What's the next thing? The next thing is to write your fraction so that the units cancel. Notice grams down here and grams up here, and so they're going to cancel. On the other side, we have the unit that we're going to go to. I've got to make sure that this is equal to 1. So how do I make sure it's equal to 1? I use the meaning of micro. So I've written down all the different ways that you can do it here. Micro is equal to 0.000001, or micro is equal to 10 to the minus 6. So if I go, pick whichever way you want to use, it doesn't matter. I go and I take and I put gram after micro and gram after 0.000001, or gram after micro and gram after 10 to the 6. And I can use either one of these as the fraction. I get this fraction right here. If I wanted to write the other one, I would have this on the numerator, and this entire thing would be in the denominator. Notice the number in the equal statement that is with the unit must be with that same unit in the fraction. Okay, so here I've gone and I've put the number in. Notice 10 to the minus 6 was with gram, so I must make in the equal statement, so I must make sure it's in the fraction that way. Okay, grams are going to cancel out, and I'm going to get microgram. And you can see that if I do the math, I'm going to enter this in my calculator as 9.109 EE, that stands for this entire part right here, the times and the 10. Don't put a 10 in your calculator. So you're going to press the second button and then the EE key. and it'll put an E on the screen of your calculator. Then you're going to press the negative and then 28. Then, because this is in the denominator, what you will do is do divided by E negative 6, or you can do 1E negative 6. Either works. Mathematically, you should get 9.109 times 10 to the minus 2. If you have your calculator with you, which you should, try this and see if you come up with the same number. If not, just bring your calculator to class and we'll learn how to do it there. The next problem is, what is the number of joules in 48 kilojoules? Again, I write down the number given to me in the problem. Next, I'm going to write down a fraction that is going to give me unit cancellation and the unit I want. I need to make that fraction equal to 1, so I put the 1,000 with the joules. How do I know that? Remember to go back to your equal statement. Kilo equals 1,000. So kilojoule equals 1,000 joule. Make sure that if the 1,000 is with the joule in the equal statement, that it's with the joule in the fraction too. Now what you're going to do is do your unit cancellation. That gives you joule left over, and you do your math. Notice here the 1,000 is in the numerator, so I have to put a times in front of it. 48 times 1,000, and it gives me 48,000. In this problem, we're starting with 1.38 times 10 to the minus 2 mole. I write that down, and I want to get to millimole. So the first thing I'm going to do is write a fraction that puts mole in the denominator and millimole in the numerator. Now what I'm going to do is put a value in that makes this fraction equal to 1. How do I figure it out? Milli equals 2.001. So millimole equals 0.001 mole. I put that in. Notice 0.001 and 10 to the minus 3 are identical. I'm going to enter this in my calculator, 1.38 times 10 to the minus 2. And then because this is in the denominator, I will do divided by 10 to the minus 3, or I can do divided by 0.001. That gives me 13.8 millimole. Be sure to do problems. We finished chapter 1. You should read all of chapter 1 and do the in-text problems as you read. At the end of the chapter, you're going to find these problems represent material that we've covered. The answers are in the pages after the questions. There are worksheets posted for this chapter and answers for them. There are Pogles for you to do also. Be sure to do the online quizzes that are posted for this chapter. You will see that the due dates are posted with the quizzes. If you need any help, be sure to come see me or see one of the tutors. You can call, you can email, or you can come into my office. I am glad to help you.